In this recording, we are going to be looking at this section, transmission of electrical power. Now, I'm not going to do it all because I think you can do some reading on the section and also look at the relevant PowerPoint, the third of the PowerPoints. But firstly, just to look at this idea of power losses. Now, because power is equal to I squared R, one of our formulas, whenever you have a resistance in a system, in a circuit, you are going to get losses due to power. This will come out as heat. Heat will be lost in this term, and as one can see, this is greatly related to the idea of your current, the amount of current that is going through. It's a squared term, so the current greatly influences the amount of energy lost per second, or the power that has been lost by a circuit. And so in electrical supply, the underlying principle is that we try, when we are transporting electricity, that we make the maximum voltage and a minimum current for the transportation. When you transport energy using electricity. So when you transport energy using electricity, you try and do it with a maximum voltage, a minimum current. And so at the start off, you would use what we call your step-up transformers. Now, perhaps to look at this in a little bit more detail, we can bring back our PowerPoint, and here we just have some more points relating to power, and perhaps we can just go back to this. So you have resistance, so you have energy loss, and remember we have the power is equal to I squared R. That's your loss. Your loss of energy. You get this hysteresis loss. This is whenever you magnetize and demagnetize, as what happens in a transformer, there is a certain energy loss there. And then you get what they call eddy currents. Now these eddy currents are small currents, actually small circular currents that are formed by magnetizing. When you magnetize something, you form these small currents, and these currents form due to Lenz's law in such a way as to oppose the change, and therefore they act as a type of resistance also. So these are areas in which you can get energy losses. So to try and minimize all of this, we've got this diagram, and this explains it in quite a lot of detail. We get our power station. Now, it's traditionally that we try and have this close to the energy source. So we have this close to your coal mine or your hydroelectric power station or so forth. And traditionally this would be quite far away from your use, so from in your city and your houses and so forth, these areas over here, there is usually quite a distance. So what happens is that we have a step-up transformer that steps up our voltage, that say coming out of the power station at 33,000 volts, steps it up to 400,000 volts. And this is the major transmission. This is the distance. This is a long distance away from the city. Then as it comes in to the city, so now you're coming into the outskirts of the city, you will have on your outskirts, traditionally cities, so you get your city, and if your center of your city is there, you would get on your outskirts, quite far away, you would get your heavy industry, and you would have a step down transformer to provide them with reasonably high voltage In this case, they've used an example of 33,000 volts. Then as you get in even closer to the city, you've got your light industry, your small factories and so forth. There would be a further step down transformer to 11,000 volts in this case. Then you got your farms. These could be all over the place, the farms, and then going into the actual city itself, your houses, your schools, your homes, your shops, and your offices. We use 230, 240, so there'll be a further step down. So overall, we've got this major step up. There's your step up, and then we've got a series of step down transformers. We've got 1, perhaps 2, 3, and these are basically stepping down the voltage so that it becomes used. You don't want, for instance, in your house to have 11,000 volts being used. It's too much energy per coulomb that you would require. You want it at a lower amount. So this is an idea of how transformers are used to transfer electricity. This is the major distance, this one over here. This is the one that I pointed. This is the distance one. And so you have it going at this very high voltage, very low current, because remember, your power is equal to your voltage times your current. So when you step this up from 33 to 400, you basically stepped it up by perhaps 11 times. The current is going to be drop by 11 times, the corresponding 11 times. So it's going to be a small current but very high voltage, and in that way it minimizes the amount of energy losses. Energy losses here, the power is equal to I squared R, is minimized over this period of space, so that most of your energy, and that's what we were talking about, energy, gets through to your consumers.